Welcome to the second tutorial on models of the atom. In this tutorial, we will explore the cathode ray tube experiment and answer the questions: what happens when a current of electricity is allowed to pass through a small amount of a gas, and what can this tell us about the atom? So, the cathode ray tube is a glass tube that's been evacuated. In other words, we put a vacuum on it and take everything out of that tube, and then add a small amount of gas to that tube and seal it such that there are electrodes in the tube. Then we take those electrodes and we hook them up to an electrical power source, and we find something very odd and intriguing happens. When we turn the power source on, there's a glowing beam of light that is through the cathode ray tube. Now, in old-fashioned televisions, we actually used to use these cathode ray tubes to light up the screen. So scientists experimented a little bit with this surprising phenomenon of having this ray be seen when you turn on the electrical power source. One of the experiments was having a magnet near the tube. When the south side of that magnet, or the positive end of the magnet, is placed near the tube, the ray was actually moving toward that magnet. It seemed to be attracted to the south pole of that magnet, or the positive end of that magnet. When the magnet was flipped over and the negative end, or the north pole, was exposed or placed near the tube, the ray moved away. It seemed to be repelled by the north pole of the magnet. So this is very interesting. If the magnet repels this ray, it must be negative. The negative end of this magnet repels the negative charge of this ray. The positive end of the magnet attracts the negative ray. So we have to conclude that atoms, even though they're overall charged neutral, they must have negatively charged particles in them. So the atom must be made of something that's positive and something that's negative. In about 1897, J.J. Thomson, an English scientist, looked at this experiment carefully and came up with this idea of the atom looking kind of like plum pudding. Now, plum pudding is an English dessert that's a cake that has raisins or currants in it. So he claimed that the atom was like a plum pudding with a positively charged region or cake with negative particles like raisins stuck in it. So I like to call it the chocolate chip cookie model because I'm more used to chocolate chip cookies, where the atom is a cookie, the dough is the positively charged region, and the chocolate chips are like the negative particles. Now, of course, it's super duper duper small, and we can't see this. Now, J.J. Thomson actually won a Nobel Prize in 1906 for this discovery of an electron and the fact that gases can conduct electricity. Now we have to revise Dalton's theory. Dalton said that the atom was a small, indivisible particle. Here, we have to make a little revision that the atom must be made of small, negative charged particles in something that's positive, because we know the atom itself is overall neutral.